Thank you. Good afternoon, everyone, and thank you for joining me today, and thank you to Chef for having me here. There is a little bit of feedback, so I'll try to position myself properly. I'm really excited to share my story with all of you. Again, my name is Michael Kristen, and the topic of my presentation here is titled DevOps in the Intelligence Community, or it's frequently known as the IC. This presentation wouldn't be possible without the help from the rest of the team, and I do want to acknowledge all those on the credit line, and I apologize if I forgot anyone on that list. So a little bit about myself. I've been a software systems engineer at the MITRE Corporation, and I've been here for about 9 years. MITRE, for those that aren't familiar, is a not-for-profit company that was chartered in 1958 to work solely in the public interest. MITRE only operates what's known as federally funded research and development centers, otherwise known as FFRDCs. We have 7 of them, and they include things like the National Security Engineering Center, sponsored by the U.S. Department of Defense, the National Cybersecurity Center of Excellence, sponsored by the U.S. Commerce Department's National Institute of Standards and Technology, frequently known as NIST. So 2 of the common characteristics of MITRE throughout our decades of service include 1, a spirit of innovation, and 2, a deep understanding of the principles of systems engineering. We do work for other parts of the government, including the Veterans Affairs, Homeland Security, Federal Aviation Administration, and others. So a little bit about who is NGA and what they do. NGA stands for the National Geospatial-Intelligence Agency. So note there's a little hyphen in between geospatial intelligence. That's how they're able to get the letters NGA out of that. They're a member of the U.S. intelligence community and the Department of Defense. And NGA delivers world-class geospatial intelligence, frequently known as GeoInt, that provides a decisive advantage to policymakers, warfighters, intelligence professionals, and first responders. NGA does a lot of things like assisting humanitarian and disaster relief efforts by working directly with the lead federal agencies responding to fires, floods, earthquakes, landslides, hurricanes, and other natural or man-made disasters. So during the response, for example, for the Nepal earthquake, GeoInt helped first responders locate areas that needed some of various aids, and overcame some of the challenges that they encountered while trying to navigate within the country. I do want to mention that they have a GitHub account, and they also have a large social media presence. So one example that we were talking about just before was that they did have a Facebook post yesterday all about geocaching and Pokemon Go. So they do keep up with the trends out there as well. So if you want to learn more, visit their GitHub page. They also have a website, nga.mil. So I encourage you to check those out. So MITRE's role as an FFRDC was to act as a trusted advisor, systems engineer, and forward-leaning thinker for NGA and the rest of our government sponsors. Over the past 2 years, we've partnered with some of our sponsors to tackle some of those challenges and topics that are emerging in the technical sector. We already started thinking about DevOps and the cloud for our internal work programs, and we wanted to apply it to the government space. We also started using Chef for our corporate managed cloud and infrastructure environments. I myself have been using Chef for about 3 years and wrote a number of cookbooks to configure that infrastructure. Some of those cookbooks I wrote I'm very proud of, and some of them I look back and say, gee, what were you thinking? So all these things started to come together into best practices that we wanted to apply to enhance GeoInt solutions for our nation. We also saw the value in making these best practices abstract and scalable enough so that it could become reusable as an enterprise service. And as an FFRDC, our goal is to share what we've discovered with the larger community, including the folks here at ChefConf. So agencies in the government are starting to shift a lot of their traditional workloads to the cloud. A lot of this momentum is sparked by the White House and the U.S. Digital Services Playbook, as it mentions things like taking a cloud-first approach to IT. But what does that exactly mean, moving out to the cloud? Well, we're still trying to figure out what it means taking those workloads and putting it in a cloud-based environment. So MITRE's role has been a pathfinder. We had an existing program that was called the Integrated Analytic Environment. It's something that's in production. It's a very small project right now, but what we decided to do is take that small implementation and use that as a trailblazer for determining the effort that's needed to move an architecture from a traditional on-premise environment to a cloud-based model. And when we did this, we didn't want to just do a lift and shift. We wanted to use all of the great benefits that the cloud brings to us. So things like blue-green deployments, immutable architectures, auto-scaling, And while we did this re-architecture and this redeployment, we wanted to work some of the harder problems, such as test and security. And doing this Pathfinder effort allows us to figure out what some of those challenges are so that we can go and report back and help other projects as they work on their journey to the cloud environment. So the transition to the cloud gave us the opportunity to work in a greenfield environment as well. So we were able to keep some of the best of deployment and development practices while figuring out best ways to deploy when starting from scratch. We also had an opportunity here to employ things like continuous integration and continuous delivery. And given our previous work with Chef, we naturally chose Chef to be the configuration management tool of choice as we started this Pathfinder. At the same time, we started to look at leveraging the wisdom of the open source community. So for example, in August 2015, NGA launched something called the GeoIn Pathfinder project to help agencies like NGA navigate the competitive world of commercialized geospatial intelligence, operating in an open, off-premise, and telework-friendly environment. The project is aimed at answering research questions using only tools, data, information technology, and services available in the commercial and open source world. In 2016, 2 of those coding projects released on our GitHub site included a social media picture explorer, which uses machine-based learning to cluster similar images. And that's just 2 examples of stuff that we've been working on. So that's all well and good, right? Well, we're off to the cloud and we're going to do great things. Well, not so much. You have to remember that we're working with the federal government here, and there's a lot of unique challenges. So generally speaking, in order to get software deployed to a production environment, there are a number of hurdles that need to be jumped through. So first of these, or some of these, are due to laws and regulations. So think things like HIPAA, FedRAMP, FISMA. Some of these other regulations or some of these other constraints are contractual. So for example, every time we want to deploy a new software system or change a major component, we need to go through an acquisition and accreditation process. A lot of these are driven by various requirements. We also have challenges with things like closed or disconnected or highly firewalled environments, and working with those is an ongoing challenge. All of this and more are various things that we have to work in the government space. And one thing I definitely want to hammer in is that security plays a huge role in this, and making sure that we satisfy controls such as NIST Special Publication 853 are very important. So once we have an approval to operate, it's not just that's not the end of the story. Changes to the environment sometimes require restarting the whole approval process in some cases. So here's something that's a very unique challenge in our environment, is that we got to work with all these constraints. And here's another one that's something very different from industry. Some government programs have laws that dictate spending of money on certain things, and they have budgets and contracts that can say, for example, only pay for research and development, while another line item can only pay for operations and maintenance. So the thought of trying to merge these 2 cultures and these 2 budgets together into one for DevOps is immensely tricky, and it's something that we're still working on. So here's our methodology that we started off with. We want to utilize Chef for deployment, provisioning, and hardening of all of our systems. And the approach we took was this idea of building low and moving high. And what I mean by that is we're starting in that open environment, we're starting and testing out everything there, and then we're moving to a staging area where we have a disconnected system, a simulated disconnected system. So if you were at one of the earlier talks, we were discussing, say, a VPC that had security groups that didn't allow outbound internet access. So our target environment in our Pathfinder is one of those closed, highly firewalled networks. So we started by testing in those open environments that mimicked a firewalled network as much as possible. But the benefit of doing this in an open side is that it gave us access to additional personnel and tools. So for example, if I forgot that one Ruby gem or that supermarket cookbook, I can quickly turn the switch on, grab that information, repackage it up, and I can continue working on that. Something that wouldn't be available on a closed network if I were doing my initial development there. One of the other things that we did in our methodology was to iterate quickly. So as soon as new features or incremental releases became available, we tried to promote them into our environment as soon as possible. While we were working all of this, we were trying to also work some things like paperwork and security accreditation in parallel. We were trying to find ways to automate security and accreditation assessments. And while doing this, we wanted to engage with the test and assessment team as early as possible so that they could be on board with our process and our culture. So here's a hierarchy of how we constructed our chef cookbooks. We structured our cookbooks in a tiered model. Following the idea that best practices of wrapper cookbooks, we separated out some of those common components that did roughly the same thing over and over again from what we deem to be what we have at the bottom, a project-specific implementation. In this case, the specific web application we were deploying was that thing at the bottom. So we started with writing some cookbooks that handled things like patching and hardening of the base operating system, since all accredited systems would require those. Then we took a look at some very common software components, so think Apache, Tomcat, MySQL, Postgres. Some of those applications have additional guidance in hardening and securing, so we wrote wrapper cookbooks for those based on what we saw in, say, the supermarket. Then we grouped all those common components into roles, and the thought is those first three boxes at the top, those are all reusable components that are enterprise-wide, so we should manage them at the enterprise level. The thought is if we can get an authority to sign off on those components, the end project only has to look at that last box at the bottom when deploying and building an accreditation package for their program. So we want to level the risk plane and maintain trust over time. So working hand in hand with the deployment of the configuration management process is the idea of automating security. A lot of what you see in these security plans is the validation of various controls. So with that in mind, we can validate our CM scripts such that cookbooks and recipes, they generate reports that our security staff can consume, monitor the environment for compliance, and if the environment changes from, say, a newly discovered vulnerability, we can update those scripts so that the validation checks will pass. The security toolchain and configuration management systems allow for direct and real-time analysis of your exposure to new and known threats. So things like InSpec and OpenSCAP paired with configuration management systems and orchestration tools provide the tooling to enable continuous reporting, remediation, and validation of the system compliance on every commit, build, or update. The configuration management system and InSpec libraries also allow for active remediation of threats, not only in systems being built, but for those already deployed in production. And the automated processes and procedures ensure integrity, consistent execution, and allowing for agile but stable capability enhancement and remediation. So our approach was to take a machine image, manage it by Chef, and then have it monitored by InSpec or SCAP. So we're building security configuration profiles that align out with our cookbooks and recipes. And they can have multiple associated security profiles. So maybe it's one of those profiles that Chef wrote they mentioned at this morning's keynote, or maybe it's something else that we wrote in-house. This captures all of the required security controls for that base profile and the application profile together. The next step is then to link those controls to code. So the security finding identifiers are embedded into Chef and the associated files for what they cover, so we can map some of that Chef code to specific remediations for a specific control. This allows us to get a full accounting of the active mitigation and also allows us to get quickly and easily build new profiles. Looking at this diagram on the right, you'll start to see that with your base node at the bottom, you layer on well-defined profiles from your various agencies. From there, you deploy your application stack and then perform that full stack analysis, possibly with additional application-specific profiles. So from a security perspective, this analysis looks very similar to the tiered approach we had for our cookbooks and recipes, except this time we're looking at it through the lens of InSpec. So we've been actively working with Chef in developing that InSpec gem that's used in Chef compliance. We've been writing a number of controls such as the example that you see here on the screen. So in this example on the right, we have a defined control that maps to a number of different published guidelines. In this case, we have an NSA STIG and a Red Hat security guide. We have a way to test for a control. In this example, we're looking at the /etc/secure-tty file to see if standard out is listed. And one of the things we worked with Chef is to develop the notion of tags. So we can tag these controls with other guidelines. For example, there's a NIST and DISA line, so that we can execute all of these validation checks, and when we do this, we can get a report that ties our system back to published criteria that our security assessors are more familiar with. Furthermore, the InSpec control allows us to rate these controls with a specific score and severity. The score themselves depend on the agency's criteria, but this allows us to rather quickly quantify our security posture. And all these things can get rolled up into Chef compliance, and we can visualize all these things while still providing all the necessary information to our security assessors. Looking at this, we're still thinking towards the future about various enhancements, so things like tagging in Chef, metadata query, reporting, enhanced CLI reporting, a standard control index, support coverage and completeness concepts, profile attributes, or signing profile and test results are all things we're looking further down the horizon as ways to augment our compliance program. So with the automated security compliance piece well on its way, it's time to change gears and revisit that issue of closed or disconnected networks. The idea is to develop an implementation of a continuous integration, continuous delivery pipeline that spans multiple security domains, supports frequent iterations and higher velocity, allows sharing of common components, accommodates development that can't be done in other security domains, includes a manual review steps and automated security assessments, and the end goal of improving overall software quality. We heard a great talk in the previous session on working with disconnected and air-gapped networks, and we feel inspired by that 60-second challenge that we heard at the keynote this morning. So our desire is to bring all of those things into our ecosystem. Our grand vision is to get our accreditation process to a point where we can operate these private clouds in highly firewalled or disconnected networks, but still take in components from the community as shown in on the left. Our automated security inspection, coupled with other great tools such as Test Kitchen or Food Critic, play a huge part in making the CI pipeline robust. But that doesn't mean we can shift everything to the left. We still have to manage merging in special changes, modifications, and other features that only exist on our disconnected side. Which leads me to the partial synchronization problem. Sometimes changes happen on this disconnected side. I've done it. I'd say that as a ballpark of what I've done, about 20% of those changes occurred because there was something very specific that in that domain that required a customization. And the other 80% as well, developers in general are lazy. So this creates problems when you have a partially synchronized repository. First off, let me make the huge assumption that there is one common point where the divergence happens. And otherwise, if that's not the case, you're kind of lost. But even so, I still had to manually resolve merge conflicts, sometimes for code that I didn't even fully understand. And then I have the problem of different version numbers for cookbooks. So for example, suppose I made a change to a cookbook on that disconnected side, and I bumped the version number of my cookbook. Do I then go and bump the version number on the lower side, or do I just work with two different versions of cookbooks now going forward? It's something I haven't really figured out what the right best practice is, so it's still open for debate. So our method right now is managing multiple clouds. We have different types of tools and different types of support systems for that. Pretty much we have two of everything, two Chef servers, two GitLabs, two Jira trackers. The idea is, even though we have all of these development environments and support tools, we encourage people to contribute to the open source side unless it's absolutely necessary. Otherwise, the open source developer community will feel left out. Also, as we're working with our Chef recipes, we're making heavy use of attributes in Chef environments so we don't have to modify those recipes whenever possible. The other thing we're doing is we're exporting our Git repos for our recipes and cookbooks, getting it scanned, approved, and then deployed, and then after all that, dealing with merging branches and pull requests. And even so, doing all of all those manual steps takes about a week to accomplish in worst case. So we need to make sure that we have all of our dependencies and make sure that all of that code works before we move it up. Nothing is more frustrating than getting a package that a coworker developed that had a syntax error and then having to start that process all over again. So looking at the major principles of DevOps, so far I would say we're doing about half of them so far. So the next step is to refine our business processes and check off the rest of those boxes. We have a number of manual steps I mentioned. So the first item is taking a lot of those manual steps and turning them into autonomous tasks, but leaving provisions in place to allow for, say, manual peer review or approvals after, say, automated tests happen. We also want to add instrumentation to each step in these processes. What we want to do is establish a quantitative baseline using current manual methodologies so that way we can measure the improvements of our business process from leveraging things like DevOps. One story I'd like to tell was of a developer who sent me a note. He said that one of the servers that he had was acting up, and he said that he tried troubleshooting and eventually gave up. In his email to me, he said, yeah, I took a cop-out, and instead I just spun up a new instance, added my server to the various run lists, and then got it up and running. And I said, well, wait, why do you feel bad about this? This is a great success story. We need to do more of this. So trying to get the culture changes in place is something that we're also working on. So what we've learned, well, requirements drive changes. So unless we had a requirement for a feature or component, we couldn't work on it because the software needed to trace back to requirements. We needed to adhere to things like the federal acquisition regulations. There's a need for a large cultural shift. We still have contractors and contracts that are working just research and development, and we have another set that's working on operations and maintenance. In some cases, this is just because of the way the contract or the requirements were written. We're hoping to change some of this. So we took an initial stab at the acquisition process, but we still have a ways to go. So I did co-author a paper called DevOps for Federal Acquisition. It just starts to skim the surface, and it really points out that it's a process that requires a lot of thought and exercise on how to bring things like DevOps into this process. So there's some political things as well. So our sponsors, in particular the security groups, have to date followed a more traditional security accreditation model. And there's still a significant manual test component. We really want to get our security teams comfortable with accrediting the process rather than the end product. And we're getting a little bit of buy-in from the top. There's some desires for, say, accreditation for a day. Those are in the works. We also have some technical challenges. I mentioned things like automated open networks to closed network source code pushes, configuring delivery tools such as Jenkins or Bamboo to pull repositories and execute tasks, so basic CI/CD stuff. And then making a lot of these tools available in closed environments will help making debugging and development a lot easier. And lastly, we have some resource challenges that we've learned and things we want to take away. So things that one of the things is that there's so much to do, and we have a very, very small team that we're working with. I'm working on trying to build a larger technical base of people who can get really excited about some of these challenges, because right now there's a lack of understanding of DevOps technologies, cloud, Chef, CM. We're trying to show the value and the benefit of DevOps so they become more popular in the organizations and more widely accepted. So that's the end of my story so far into DevOps. Our journey continues, and I encourage you to join our community. We do have a presence on GitHub, and so far we have a few cookbooks already up there, and I'm working on cooking up a few more this summer. I also encourage you to reach out to us via email. Our team's email address is up there. And so with that said, I'd like to thank you for your time and attention. I'd be happy to answer some of your questions, and also I can make myself available afterwards for some of your questions offline. So once again, I'd like to thank you, and if there are no further questions, I'd also thank you again for your time and enjoy the rest of your conference.